Hello and welcome to Future Decoded. It's live, it's November the 2nd, and we're going to be talking about robots. Joined by Rob. Hello, Rob.
Hello.
Rob Miles. What are you doing nowadays, Rob?
As little as I can. I'm now a technical author of some sort.
Oh, wow.
And so I write things on walls and other places.
Well, I've just learned to read, so that's a good start.
We'll do colouring in.
So what are we going to be talking about today then?
Okay, what we're going to do today is we're going to look at robots. We're going to do two things. We're going to make a robot that actually attaches to the internet and you can do things with.
Right.
And then we're going to look at how you can use speech to control that robot and tell it what to do.
And you're going to do this in 30 minutes.
And I'm doing this in 30 minutes. So I'll just set my watch. Jolly good. Okay, so so we're going to have to go to fairly high speed here.
That's fine.
That's
I'll
okay.
do the speed.
How to build a robot, how to actually get it to talk to the world in a useful way, and then once you've got your robot going, go and into the cloud make an actual chatbot that you can then use to control the robot and make it do stuff. And if we do this right, and I intend to do this right, then we should be able to have people out there in internet land, hello, who can actually try and control the robot and make it do stuff.
That's dangerous.
It is.
Let's do this.
It is. What could possibly go wrong? Stick around and find out. Okay, so let's build a robot. Now, for building a robot, there's several different platforms you can use.
Yeah.
You can get for the good old traditional Raspberry Pi, which everyone seems to love, and it's a very good value device and great fun. It's very powerful. It can run Windows 10 beautifully. And you can do all kinds of upgrades and all kinds of nice stuff. It's a bit hard to connect, and bearing in mind I'm building my precious robot for £10 component cost.
Oh wow.
In that case, the Raspberry Pi kind of blows that. Can't do that. That one's gone. So you go and look at the Arduino, which is a very, very popular tiny device. If you're a programmer and you aren't into the Arduino, you aren't a programmer. you should be playing.
I won one of these.
Pardon? You
I
won
one? Yeah.
Wow.
For a Raspberry Pi hack thing that me and Martin Campbell.
Cool.
We won some Arduinos at a hack conference. Yeah, it was quite a hack conference. No, a hack fest.
Cool.
Thing. Yeah, it was good. But I've not yet. Maybe I'm not a real programmer, so I've yet to use it. But
They are great because you can write C and deploy it, and it just runs, and it's wonderful. It's about £2 or £3 to buy, but it's dumb, very dumb. You've got 32K of program space and 2K of memory,
wow,
which is tiny. It's great for low-level control, and it's not very connected. So you go off and look at this guy. This is called the ESP8266. And if there's one thing you take away from this presentation, it is that magic number, because this thing is awesome. Costs about £3. You buy it in a variety of different formats. It's internet connected, built in. So for that price, you get a device which you can put on the internet and address, and you can drive it through a Zero IoT hub and all kinds of other things, and it's fundamentally awesome.
Yeah.
So that's the thing.
So awesome they didn't even bother giving it a good name.
Well, they didn't need to.
Just
the old
just some numbers.
8266, absolutely. There's a new one coming out which will be even better. I mean, it has one or two foibles. It's a bit fussy about power supply, and it's actually available in the different formats and whatnot. A bit confusing, can be, but you can make it a Wi-Fi client, you can make it an access point, and a web server. So you can have this robot can be a web page, which you can access from your phone straight away, which is just stunning.
And how much did you say something like that would cost?
The chip itself, you can have them for about £3 a pop.
Oh gosh.
So if you're thinking in terms of anything connected, this is your go-to guy.
Right.
And it's what we have on the robot, as I shall show in a second, is this little device here, which is called the Wemos D2, which you can pick up from a site called AliExpress, which has got loads of stuff you can get sent from China, and you can pick these guys up for about £3 a pop.
Oh wow. Right.
And they're stupidly cheap. One thing, I'm going to go quite fast, folks, but all these slides and everything on them are going up straight after the talk. So if you don't get anything, don't worry, it's all here. You can read through later. But the wonderful thing is you can even write code for these guys using Visual Studio, because there's a thing called Visual Micro you can plug in the studio, and that lets you actually write the code in your favorite environment of choice.
Okay.
And you can deploy it, and there's even some debugging support. It's not great, but it does sort of work. Right. So you're now writing C in an embedded device that can talk to the internet because it's got Wi-Fi built in. And what I use in my robots is two processors. I have an Arduino which controls the motors and the lights, and I have an ESP8266 which controls the internet connection. And I have a link between the two, which is how we get the commands down from the cloud into the ESP, and then over the serial port into the Arduino, and then the motors turn and lights come on, and all kinds of good things happen.
Wow, okay.
That's how it works. So this is a dual processor robot for less than £10 component cost.
And in terms of deploying your application onto it, there's a USB port, is that
Yes,
how that
you
works?
plug a USB port in there, other end into the PC, and then you just download the thing from Studio and it runs. It's stored in it's in E2 PROM memory, so unplug that, turn the power on, next time the code just runs in here straight away.
Right.
So programming is quite easy. Same thing with the Arduino, same kind of technology to do that. You can update these guys from the cloud. You can actually push things in over Wi-Fi, but I've never tried that.
Yeah,
it is possible, and it would be awesome, but I haven't done it just yet. We'll have to see how that turns out. So, yep, there's lots of Wi-Fi options you can get with this chip, and so it's worth playing with them all. There's some nice example apps as part of the Arduino framework, which you can then deploy using Studio, and there's all kinds of ways you can connect it. We're going to use a thing called MQTT, which is Message Queue Telemetry Transport. That's a good thing to impress your friends with.
Yeah, or MQTT, that sounds better, I think, yeah. It's the sort of thing which I'll learn that acronym once and then never remember what it actually means.
It's a good pub quiz question if you're in that kind of pub.
It's very
specialised pub, yeah. About 3 pubs near Reading where that would work. Apart from that, nothing. But this is an industry standard. It's out there. If you look at IoT devices all over the place, lots of things use MQTT. It's a standard protocol which lots of things can hook into. It's a very simple packet structure. It runs over Wi-Fi or serial port or whatever you're actually working with. And it runs on my little embedded device as well. And this is a robot, which is fine. But if you wanted to do things like track the temperature around your house, if you wanted to do things like any kind of embedded sensing application, you would use MQTT for that. It's publish and subscribe, so basically you have a server and you can push things into it and subscribe to events that it generates.
Right.
And it's designed to be used this way, so you could have all your house sensors around the place publishing information, and then a client program pulling things down and annotating them and drawing graphs and all that kind of good stuff.
Okay.
So there's a lot of serious intent here in terms of how to make it work. As far as I'm concerned, the reason I love it is it runs on the Azure IoT Hub. So as far as I'm concerned, I go into IoT Hub, I make some keys up, I create some devices, I can then deploy programs onto this thing which will talk straight into the cloud. And it's really quite easy to do. And so there's a client you can find on the interwebs called PubSub client, and I got a modified version of that. I'll put all my code up on GitHub so you can see how it works. But basically, you build this piece of magical code, and you can then push messages from this device into the cloud and get messages coming back down the other way to tell it what to do.
Wow.
And so, if you look at how it works, this code is C. It's running inside the robot at the moment.
Right.
And if you look at what's happening, it basically starts 2 serial connections, one for diagnostics and one to tell the robot what to do. It then turns on the Wi-Fi. It then says, I'm going to put an MQTT server on port 8838, which is where Azure likes to see them.
Okay.
And then it says the callback method will be called when we get a message from the server.
Okay, so it's going to be listening for the robot's going to be listening for instructions on port 883. Something's going to, in this instance, Azure IoT Hub's going to send signals to it.
That's right.
And it's just subscribing to those.
That's exactly right. But that's the code. There's nothing more to it. It's a bit more complex. There's a reconnect method, which is also called and runs inside the robot, that basically connects the device to the endpoint on Azure Hub. Yeah. And this is where you get your great big signature keys, your big pieces of guacamole, which you download from a provisioning program into the device so that we have a secure path. Because the thing I like about this is that if no one gets that key, they can't spoof your device.
Okay.
So it's got a modicum of proper security in place there, which is kind of nice.
Which is being slightly undermined by the fact that we're publishing this to the web on a video now.
You'll probably find that doesn't work.
Oh, right.
On account of Robert having added some extra bits and pieces.
Good thinking then, because I'm never thinking ahead like that. That would have been my life.
Let's play a game called Robert Isn't an Idiot, shall we? Not many people play it, but I'm happy to have a go. When we get our callback, all that happens in this case is we take our payload message, which is basically a lump of bytes,
right,
and we assemble a string, and we send that to my coprocessor, which tells the robot hardware what to do. So Mr. Arduino takes over at that point and actually acts on it. That's what send robot
So the messaging system is just bit streams, right?
Yes.
And then we
So
can put that into strings on the
you
front.
can put whatever meaning you like. I mean, you can assemble a little piece of JSON and send that back. That's a good way to do it. And then the receiving thing gets some JSON, put it into an object, and then away you go. That's a good way to do it. But as far as we're concerned, these things are lumps of bytes. You do with them whatever you like.
Very cool.
It's as simple as that. So that's our decoding method. And then we look at the Azure IoT Hub. Now this is where you manage your endpoints, okay? So you go onto the Azure portal and you say, I want to make an IoT hub, please. You give it a name. You then get an endpoint address. You then run a little program, which I'll mention in a minute, which actually build the keys to authenticate your various devices, put them in the devices, and then away you go. Okay. So it's actually, the workflow is quite good. You get this thing running, and then you have this little app called Device Explorer. And Device Explorer provides the device management and the testing, and you can view messages from network clients and whatnot and send things through. So what I'm going to do now is the scary bit.
Wow.
I'm going to actually turn my robot on. So here he is. So it's almost demo time. And the robot wakes up and he flashes blue and red until he finds a network connection. And that hasn't actually worked. Let's try that again. When this goes off and then goes green, that means that it's found the access point. And in a second it will go green. Please go green. Please
Come on,
go green.
green.
Come on, go green.
We are the most hostile Wi-Fi place
It's
in the
reset.
country.
Let's turn that. Let's double the. There you go.
Oh,
it's
green.
It's gone green.
Green.
What green means I have made a connection to the internet, and I have actually also found my service point in the Azure IoT Hub. So what I can do now, I'm getting ahead of myself here, but why not? Is I can go into my desktop. I can fire up the IoT Hub program, which is this guy here. Now this is a program that you get as part of the package with the IoT Hub, and basically what it's letting me do is push things into the cloud, which will then get reflected down via MQTT into the robot.
Right, okay.
And if I look in my message to device thing, I can let's pick Red Robot from there, and let's send it the magical command PC pixel color 255, 0, which is all the red, none of the blue, and none of the green. And then we hit send, and this will send a message from the cloud to the robot,
oh my gosh,
which turns red.
Look at that.
Now, it is dead easy to do this, okay? I'm doing it from an application that's been pre-supplied as part of the demo. You can pull this down as an app, which you can use for just hurtling around and playing with.
Yep.
But there's also an API behind here, which you can hit again, which is very easy to use. And again, you feed that strings, and it pushes them up into the cloud and back down to the robot. So if you have an application where you want to make an internet, let's go to look at the white robot is now connected. So if I pick the white robot,
There are more than one robot.
and I hit send,
There is more than one robot.
then the white one turns red as well. So we're really on a roll here. This is going startlingly well. But what I want you to understand is that we have a mechanism now where you can buy a device for £3.
Yeah.
You can plug it in, program it up with Studio.
That's amazing.
You can then attach it to IoT Hub, and you can then drive it from the cloud. And because this sits on the back, and you can attach to it from any of your existing Azure applications, then that means you've now got a direct bridge from the cloud to your device.
Which is pretty incredible, given the fact not only is that awesome, but we're in a place which is so difficult to get any kind of connection to. I don't think I can get my phone or my laptop connected. You've managed to get two robots that you built connected somehow.
That's because I rock.
It is, yeah. The man, the legend.
Absolutely.
Rob the legend.
Corns cut
Hashtag.
while you wait. Okay, so we're halfway there. We've got the robot, we can send it commands, we're kind of making progress there. This is kind of nice. What I want to do now is look at the chatbot side. So if you have an application which you want to effectively have some Internet of Things endpoints, this is a good way to do it and a good way to start.
Yep.
Now I'm going to look at the chatbot side, which is the other end, where we're going to actually have a bot that people can talk to from their phones or from Skype or from whatever. Now, a chatbot, I don't like the name, it implies chat. Whereas in fact, what you want to do is book a haircut, reserve a table at a restaurant, or do something like that. You don't want to have a conversation about the price of fish or trees in forests. That's not what you're doing. You have a particular specific purpose.
Yep.
And in terms of how we regard chatbots, then that's the best way to regard them. So this thing is not actually clever. You can make it clever, it's hard work.
Yeah.
But your users will come to this with a desire to do something, and your chatbot provides a good way to do that. Rather than make an app that users have to buy, download, configure, blah, 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 you put a chatbot up there, they hit it from Skype or from a web park or whatever, and then they're talking to your bot. So that's the context for these things, is that we're not talking about a thing which is clever, it's got to be useful. I don't really care about what's behind there. My chatbot code, as we'll see in a minute, is rubbish.
All right.
Because all it has to do is take the command blue and make that robot go blue. That's all it has to do.
Yeah, you're saying that's rubbish. I'm going to be impressed by that. So if that works,
it's a switch. That's all it is. There's nothing to it. So as far as we're concerned, we've got a bot as a wizard, and on steroids, and you aren't going to go far wrong. That's kind of where you want to be with this. You can make them clever. There's a thing called Lewis, which is quite useful for natural language, and there's even a thing which will detect when your user is becoming upset, so you can think in terms of bringing a person in.
Yeah.
So design a workflow for this thing, and if your bot gets confused, there's no dishonor in saying, I'm ever so sorry, I don't know what's happening here, I'll get a person in, and open up a Skype call to a customer rep who will come in and sort things out. So keep the bot in its context, in its little box, it'll be fine.
Lewis is fantastic. It's actually the idea of converting natural language into intent and specific intent.
It's
which
really
is,
good.
We use it on howhappy.co.uk to, you can say, show me the third happiest person in the room, and you upload a picture and it will show you the third happiest person in that room. But you can speak to or ask that question any way you want, because, well, roughly any way you want. But it's very easy to use, it's simple to train as well. Lewis.ai is the website you go to.
Okay, I haven't played with Lewis.
It's incredible.
I'm happy with my Switch, but I have heard very good things about it. In terms of how it works, you have a web service, which is your bot. You have a connector, which links you to all the various communication mechanisms, and the bot connector does the clever bit and the glue, and you just write the web service. And you can write these things in C# or JavaScript and Node or REST API, and there's some nice getting started stuff out there. We're going to be using C# because that's the best language in the universe.
It's just an MVC controller at the end of the day. I think it's a 4.6 MVC controller.
There's nothing to it. In terms of what you do, here's 6 steps. Make the project. You can build it as raw code. You can use FormFlow to build a dialogue. You can make it text-based. You can make it put buttons up for people to press. If you're booking a haircut, morning, afternoon, Thursday, Wednesday, Friday, just do that. It's much easier than people having to figure out what they have to say. So make my studio project. It's a download from GitHub. You bring down the project type, you then make the thing, and away you go from this template. It looks a lot like an ASP page, because that's pretty much what it is. And so as far as you're concerned, what you get is its endpoint. Before you do that, though, you register this thing. You give it an existence out there in botland.
Yep.
And so you give it a name, a handle, a bit of description. I call this thing the whole pixel bot. And so you can send things to it. It is kind of out there, it's still in a work in progress. It'll work for me, it might not work for you because I haven't published it properly. All this is control these 2 robots, nothing else. Okay? But you put this stuff in and then away you go. You give it an endpoint, which is effectively where the messages are going to be hit against on the web, and that's what our client code's going to actually run with, and you give it another piece of magical secrecy app ID type stuff to get this thing authenticated. You make the app ID and the secret, and then you put those in the web.config file of the bot code before you put it in the cloud.
Okay.
That's how it works. This is the process of doing it. I've scripted everything out for maximum security, and then of course I've showed you it in the web config. But that won't.
No,
it's not working. No. It actually says.
Don't try. Definitely don't try.
It says. Not me, folks, or whatever. So yeah, but it's as simple as this. Now you've tied the application you're building to the bot up there in the cloud. So at this point, what's going to happen is if someone says hello to my bot, a message will fire inside my app, which basically says, he just said hello, what do you want to say back?
Yep.
And that's kind of how it fits together. So we now write our code. And there is a thing called the bot emulator, which is another free download, which you bring down, and that actually lets you type commands which then get pushed onto your app running on localhost.
Yep.
So you debug this thing on your PC. You can do everything on the PC that you'd like to do to test it out, then you push it in the cloud, and then everybody in the world can see it.
Yeah, and for PCs, use that one, and there's a command line interface for that as well if you're using a Mac as well. So you can build these things.
It's very, very easy to do. In terms of configuration, you put your app ID and your secret into the actual test program on your PC, and then the one gotcha which I found is that the local host that the application when it's running publishes itself moves around.
Right. Yeah.
it uses different actual ports. So make sure that the number there agrees with the one in your bot specification. Otherwise, you spend half a day going, why doesn't it work? Why doesn't it work? And it's because that number's wrong. And I actually did that, but with stronger words.
There with the wrong port number.
Stronger words. When you get your message, you basically get a post, and this is what you see coming in. And so you have this thing called an activity, which is the most interesting parameter. That basically gives you the context of the conversation.
Yep.
And that gives you the message that's just come in, plus everything else, plus an ID for the client, plus everything else that you'd like to see. And once you've got that, you can then create a response. This one actually measures the length of the input string and sends it back. This is the default application you get with the startup project, but you can put what you like in there. There are also system messages which you can use to sort of manage things like the user started typing something, or there's all kinds of other bits and pieces you can use in there to do with. I don't bother with that for mine because I don't need that. I just take the word forward and I pass it to one of the two robots. That's all I do in my client code. And so, the activity has all this context stuff, which is great, but I don't do anything clever at all because there's no point in this particular context. I just want to prove that the thing works.
Yeah.
And let's see if we can actually make it go. So, let's try talking to the Help Pixel bot. Now, I can start my program. Let's run some code. How could this possibly go wrong? So I open up this thing. We've got 6 minutes, folks, so no pressure. So this program is what's running in the cloud at the moment.
Yep.
So I'm going to run this, and nobody just turned. I think someone's found the web page and made that one go blue. I haven't. I'm going to run this program, and then I'll start up the actual chatbot code, and I'll show you what it does. It'll be going any second now.
Do you believe someone is changing that colour of that robot?
It's quite possible. It can be done. So now if I open up my program here and take a look at the code, here you go. Mm-hmm. This is the code which does my robot command decoding, and it's basically...
Oh, right, okay.
I take the string, I make it lowercase. If it's the word forward, I send the command mf10 to the robot. If it's back, I send mf-10.
Okay.
And these commands get picked up by the robot as MQTT messages and then pushed into the Arduino, which goes, okay, move forward or move back or change color or whatever. So I run this guy up. And it's on localhost 3979, which is a nice number. And this is basically now sitting out there on my machine. I then go on to here, and so now I've got to find my bot framework emulator. I talk to that, and let's see if this works, shall we? So now I can go into here, perfect fit on the screen. Let's try that. So now if I say, I don't know, green, green, bang. That gets pushed up into my application, which then pushes it into the cloud, which will in a minute come back with a response telling me which robot it's trying to talk to. And one of the robots turns green, so I'm controlling the red robot from my bot. And so now if I type yellow, it will go yellow.
It will go yellow. Look at that.
It will go yellow. Now, if you go onto the interwebs, and anyone at home can try this. If you go onto Hull Pixel Bot. .com,
yep.
Which is the website for the whole Pixel bot. It's actually hung off my blog because everything's hung off my blog. There's a manifestation of the chat application which you can place on a web page, which is this guy here. So in here, I can send, I don't know, blue, and that will get sent to the robot again. So anybody can hit that. So if anybody wants to sort of go on to Hull Pixel bot and send commands, they get pushed through my bot.
Red,
that's probably because it's crashed.
Green.
Yeah, so maybe people out there are changing colours, I have no idea. This is all part of the fun. You can make it move by saying forward and back and left and right as well, which is kind of cute. But just to get back to the plot, because we've only got about 5 minutes now, once you've got your bot code running, as you've seen,
yep.
You then push it into the cloud, which is basically just an Azure cloud deployment. Now, a point worth making, this is all open source. You can get all this code and put it where you like. So you don't have to use Azure to host it, but it's a very nice place to do it, and it works really well. And it's a Microsoft conference, so please do. You can take your thing, hit publish, find a target, make a new app and slap it there, take the service plan, hit deploy, and it's about 30 seconds later, bang, it's up there. and at that point you get the thing running. If it's a bot like this, you will get an address book entry in your copy of Skype, so you can test it using Skype on your machine,
right,
which is kind of awesome. I can do that too, and that works. It's not publicly available yet because I haven't published it.
Right.
And there's a process by which you have to have an application vetted before it goes into the directory of addresses for bots in the cloud.
Right.
Which this one's a bit trivial. It might not actually make the cut, I'm afraid. But
yeah.
if you have a real world app that's properly useful,
yeah.
then you follow this process. But once you've followed it, you have at that point got something which the outside world can interact with, push commands up, your code can then do whatever it needs to do with and pass responses back. So this is really quite easy to make,
yeah.
which is kind of where I'm going with this. So, yep, in terms of rounding things off, yep, you publish it on the channels that you want to use. You saw we're using Skype and the web page thing, but there are other ones you can use, Slack and other things as well.
Messengers are really good.
Yep.
Messenger's a very good one for demoing as well. I think it's,
right.
it's very good for the picture integration they have.
Yes. So it all hangs together, and then when you make your web chat, it's basically a piece of it's an iframe you drop into whatever page you want to do, and then away you go. So there's a whole Pixelbook one you've seen. You can have a go if you like, and I see people have been doing. We've got different colours appearing, which is kind of cute, and that's basically linking bots to robots. We've got a bit of code in the robot that receives it. I've got some text that tells you how this works. That's the key that you make using the thing I've already seen. You have a connection string which you place into the code, which is all fine, and that then gets pushed down. There's some sample programs that show you how to do this, which are all rather nice. This is the code that runs to send the message from the cloud into the robot, 3 lines.
Wow.
So that's pretty much it.
Amazing. Wow. In 30 minutes, you showed us how to build a bot.
If
You
you're
showed us all these
making
demos, they've all worked live. That was incredible. The man, the legend, Mr. Rob Miles.
Thank you very much.
Thank you very much for listening.